This video is for Chapter 8, Section 3. It's all about the tangent ratio and our first introduction to trigonometry. Up on the board right now, you'll see a bunch of triangles where if we combine what we've been studying, we should recognize that we have the 3, 4, 5 right triangle and the 6, 8, 10, the 9, 12, 15. These are three Pythagorean triples, and they are all similar. This is very important to notice that they are all similar because the ratio 3 to 6 is 4 to 8 is 5 to 10. 3 to 9, 4 to 12, 5 to 15. These are three similar triangles. Why this is important is for us to understand that angle A is the same in every single one of these triangles. The angles are exactly the same. Here's another set of similar triangles, the 45, 45, 90, in which we learned in the previous lesson, the legs are 2, 2, so the hypotenuse is 2 rad 2. 3, 3, 3 rad 2, 4, 4, 4 rad 2. Again, these three triangles are similar, either by angle, angle, or side, side, side. Finally, I have my 30, 60, 90 triangle, in which I have 1, 1 rad 3, 2, 2, 2 rad 3, 4, 3, 3 rad 3, 6. What we're going to look at is the idea that these triangles have very specific relationships. And that relationship is, we're going to look here, from angle A, I want to look at the relationship between the opposite side over the adjacent side. So from angle A, the opposite side is 3, and the adjacent side, the one that is next to it, is 4. Now the first question you should be asking, and what you need to put in your notes, is that when I say adjacent side, there are two answers, 4 and 5. But 5 has a name. It's called the hypotenuse. So I will call this adjacent and this opposite. I will never call the hypotenuse the adjacent side. We already have a name for it. Opposite, adjacent, hypotenuse. Check out the relationship. It's 3 over 4. How about this angle A? 6 over 8. And from this angle A, 9 over 12. These are all equal to each other. They become 3 over 4. So what I've learned is that in the 3, 4, 5 right triangle, across from angle A, the relationship is always 3 to 4. The opposite to adjacent ratio is always 3 to 4. This is not a similarity ratio. This is just the relationship between the opposite and adjacent from angle A. Well, how about this? How about from 45 degrees? Let's look at opposite over adjacent. Okay, in this triangle, the opposite over the adjacent. So opposite is 2, adjacent is 2. So that would be 2 over 2. In this triangle, it's going to be 3 over 3. And in this triangle, it's going to be 4 over 4. Well, all of those go down to 1 over 1. Here's what I find interesting. 3/4 and 1 are not the same thing. What I can tell you right now is that means angle A is not 45 degrees. Because apparently if it was 45 degrees, the opposite adjacent ratio must be 1. We just learned something. The 45 degree angle has an opposite to adjacent ratio of 1. Well, let's check out what the 30, 60, 90, how about from the 60 degrees? So from 60 degrees, let's take a look at opposite over adjacent. So opposite over adjacent, radical 3 over 1 And in this case, it will be opposite over adjacent, so 2 radical 3 over 2. And in my biggest one, it's 3 radical 3 over 3. Okay, now I can reduce this. This becomes radical 3 over 1. The 2's cancel out, the 3's cancel. It always becomes radical 3 over 1. Well, radical 3 over 1 is not 1, and it's not 3/4. So, radical 3 over 1 is the opposite to adjacent ratio for 60 degrees. 1 is the opposite adjacent ratio for 45 degrees. We're on to something here. It appears 45 degrees has its own opposite to adjacent ratio, 60 has its own, and whatever this angle A is, it has its own. It turns out every single angle measure from 0 to 90 degrees has its own opposite to adjacent ratio. And that is what the tangent ratio represents. The tangent ratio of an angle, okay, is the tangent of x degrees. Now this is an abbreviation, and this x degrees can be anything from 0 to 90, is always equal to the opposite side divided by the adjacent side. So something we just learned is that the tangent of 45 degrees will always be 1 over 1. We also learned that the tangent of 60 degrees will be radical 3 over 1. And there's some angle out there that has a tangent that is 3/4. But every single angle measure has its own tangent. Now at this time, before we go further with this video, it's very important that you go get a calculator. And that calculator needs to be a scientific calculator that has sine, cosine, and tangent on the calculator. I'm going to go get my calculator, and we're going to start looking at how I can use the tangent ratio to start solving and understanding trigonometry. Okay, got my calculator, and you should have one too. At this point, you're going to be looking for a calculator that has sin, sine, cos, cosine, and tangent, tan. Tangent is the only one we really care about today. And you need to experiment with your calculator to make this work. First, I'm going to take my calculator that I have here, and I'm going to type in tangent 45 degrees. And I'm going to put in, and this is important, look on your calculator, make sure it says DEG. That means degrees, not RAD. If it says RAD, you're not going to get any answers. So I hit equal, and my calculator says the tangent of 45 degrees is 1. Wait a minute, the calculator knows all these? Hold on. What's the tangent of 60 degrees? Calculator says it's 1.73. Well, wait a minute, that's not rad 3 over 1. Unless, maybe I should check, what is the square root of 3? So I take my calculator and I go square root of 3, 1.73. My calculator appears to know all the tangent ratios for every single value. I could ask, well, let's see, what is the tangent of 10 degrees? I'll take the calculator and I'm going to go ahead and I'm going to punch in tangent 10. And I get 0.16. It's approximate. It's been rounded off. 0.176. If I want the tangent of 37 degrees, it's going to be approximately, well, let's find out. Tangent 37 degrees. And it's about 0.75. So it appears that every single tangent rate, every single angle has its own tangent number. Could we use this? And the answer is yes. Let's do some examples. And what we're going to do in class is examples. So I'm just going to do a couple real fast for you to take notes on, and then we're going to just do these in class. So here's my first example. I've got a 20-degree angle in a right triangle. So I claim that this is similar to all triangles with a right angle and a 20 degrees. So the opposite side and the adjacent side must have a relationship. The tangent of 20 is equal to its opposite side x over 10. Well, at this point, I could multiply 10 by both sides, and I have 10 times tangent 20. But my calculator can tell me tangent 20. Hold on, let's find this. Tangent 20. Now I'm going to get this as 0.3639, or it's going to be 40. And now I can multiply this by 10, and I get 3.64 is approximately x. I just found the opposite side. X is 3.64 because the tangent ratio is always the same for 20. The tangent of 20 is x over 10. And we have solved this. I could do on the calculator the whole thing. I could type in 10 tangent 20, and it will tell me 3.64. All right, let's take example number 2. I've got a 65 degrees, I've got an opposite, and I've got an adjacent. So, go to the tangent ratio. The tangent ratio of 65 degrees should be the opposite over the adjacent. Now, this is new. Last time I could just multiply by 10 on each side and it worked out nicely. Well, this time I'm going to multiply by x. Remember, these are just examples to write down. And now I have x times tangent 65 equals 8. Well, tangent 65 is just a number. I can type in tangent 65 and the calculator tells me it's 2.144. So technically what I'm going to do is I'm going to divide by that number. And I need to make sure and do this right. This is really 8 divided by 2.1445. But I can usually on my calculator type in 8 divided by the tangent of 65 degrees. And my calculator can hold and understand that. So I get 3.73. And I just found what x is. It's approximately 3.73. Because the tangent ratio for 65 degrees never changes. It's 2.145. So this has to work. So my final example right here is the one we've been sort of heading up toward. There's that opposite. There's that adjacent. But this time my tangent of x degrees, x is my angle, is 30 over 40. Or, as I just found, 3/4. It's that angle from the beginning of the lesson that has a tangent of 3/4. What is that angle? Well, if your calculator knows the tangent of 10, the tangent of 37, it must know what angle has 3/4. And there's a way to go backwards. X equals the inverse tangent. We're going to tell the calculator that not to find the tangent of 3/4, we're going to ask it a question. What number has a tangent that is 3/4? So the way to do that is on your calculator, look for the second button. When I hit the second button and then I hit tangent, I get tangent -1 and a parentheses. At this point, I can put 3 divided by 4 in the parentheses and close it. So this is exactly what I have written on my calculator. I put second tangent, and that gives me the -1, 3/4. When I hit enter, it tells me that x is approximately, it says on my calculator, 36.8. Well, you know what? That's approximately 37 degrees. Because the tangent of 37 is approximately 0.75. 3/4 is 0.75. That angle that we were looking for earlier is approximately 37 degrees. That represents the three ways that you can use the tangent ratio. We're going to talk about it a lot more in class, but to take away from today, remember, the tangent of any angle in a right triangle is the opposite side over the adjacent side. The tangent of 20 is x over 10. The tangent of 65, 8 over x. The tangent of x, or 37, is 30 over 40. Can you identify the tangent ratio? And these are the three ways to use it. That's it for Chapter 8, Section 3. You can begin working on this assignment.